Hello? You can hear me all right? I think it's working. Good. So, first of all, welcome to this coding live stream. If you are new to my channel, let me just tell you a little bit about myself and what you can expect from this live stream. I'm passionate about machine learning, 3D, Python, and coding in general. I consider myself a full stack developer with good experience in the cloud. I'm not a data science. I'm not a data scientist, in case you're wondering, but I have worked in a couple of commercial machine learning projects, mainly doing Mlops. In this live stream, you'll see me working on a variety of passion projects I've always had for many years. I might actually be just learning something cool or looking at a new machine learning paper. And nothing of what I'll be doing, like during this coding live stream, will be scripted. I'll be, for sure, I'll be learning something new as I go along. And to be honest, I don't, even if I wanted to prepare everything and script everything, I can't, because I don't have enough time. And that's why mainly I've gone for the format of a live stream. And also because I think you'll get more value out of a coding live stream, where you can see, basically you can see how someone actually will work on a problem and figuring out. A lot of Stack Overflow, obviously. But you know, there's other interesting other interesting things you'll see in the live stream, and problems, questions that you probably will have if you are trying to tackle the problem on your own. But if you see me actually tackling it myself, you will be able to save time, really. If you are watching me live, please say hi in the chat, and feel free to ask any questions. Or if you're watching this on the replay, just put a comment and say hi, and then any questions you might have, you also can ask in the comments. Also, if you have any things you would like me to cover at some point in the live stream, let me know. If I can cover, I will cover it. I normally have a live stream more than once a week. In fact, recently I've been doing it quite often, almost every day. I can't promise that's always going to be the case, but if you subscribe to the channel and you press like the notification bell, you will know when I go live. Yeah, and I also use quite often the community tab now. If you know, I'll post something also letting you know beforehand, and also YouTube will tell you, because I normally schedule it in advance. At least like I normally schedule in the morning of the same day. And yeah, before we get started, don't forget, well, whatever you wish, but don't forget to, if you like this coding live stream, don't forget to click the like button, and if you have any, if you're looking for the source code, anything that I'm actually covering here today, you will be able to check the description later, yeah? But I should already have some source code in the description, so you can check it out now. And so today's plan, first of all, I'm currently working on training an image classification model for my Raspberry Pi. I'm using a dataset I gathered from the internet and from my Pi camera. It's already in Kaggle. Today I'm going to finish off refactoring Jupyter Notebook, which I've started a few live streams ago. And I think today, this is a day I'm actually going to be able to look at the Raspberry Pi. I'll revisit some source code I've already written for the Raspberry Pi in the past. And let's do some architecture diagrams, hopefully today. All right, so without further ado, let's get started. Okay, so I'm going to so I'm going to rerun this notebook. Oh, I need to upload a file. First of all, the Kaggle file, because I'm downloading a dataset from Kaggle, but I need a Kaggle JSON key, which I've already generated beforehand. Let me just make this a bit bigger. Can you see that there? Should be big enough. Right, so just take that. So I think this should be okay. And the letters should be big enough. If not, I can still make them bigger. 10-50% is quite big already. Okay. But now, let's run this. So I'm installing Kaggle and just downloading, putting the JSON file for the key, with the Kaggle key in the right place. No, I need to rename it because the name is not. So it's downloading the dataset. Display cells. The only thing that I'm missing is the Tensorflow. So this notebook has two sections. One is to train the model and do some experiments, right? And the second section is to convert the model to Tensorflow Lite. Yeah. It's still done in the dataset. It's quite big actually. It's like 3 gigabytes at least. No more. So this function is basically it's copying all the images from Kaggle input to Kaggle working. The reason I'm not in Kaggle, but like I'm trying to make this notebook compatible with Kaggle. That's why you see Kaggle input and Kaggle working here. I only had to move this notebook from Kaggle to Google Colab because the current version of Tensorflow in Kaggle has a very annoying bug. Another thing that this copy process is doing is actually resizing all the images, keeping aspect ratio, but then instead of cropping, it's actually adding black bars to the image, so that to make it a square. Here you can see all the images that we have. This is already run, so I'm just some beautiful foxes here. Then we have the birds. This is almost look like a seagull, but it's something else. Then we have our friend cat. Ooh, this cat is a bit sad. In the cage, that's normal. This is not exactly how the cats are in my garden, right? So, anyway, I've seen all kinds of cats. I always get surprised when I see one here. In this dataset, actually. So this dataset, just so you know, it's not gathered from my garden. This is gathered from the internet. There's some happy cats and there's some sad cats. So I'm not explaining the notebook because I've kind of done it countless times in the previous live streams. So, because this is a series, I recommend you to go back one. In the previous live stream, I've gone through a lot of detail already on this notebook. Okay, so seems like I'm missing. Oh yeah, I had a bit of an accident. In the last live stream, I did a lot of refactoring, and then I was so happy about it, and then I closed the browser at the end of the live stream and I forgot to save it, so I lost all my work. So yeah, that's why it's missing some source code. So let me just find it, but I have it somewhere, so it's not the end of the world. Random dataset test. Which one did it fail? Dataset training. Datasets here. Put it here. So this code basically gives us an overview of what is in the dataset. So this one is for the internet dataset. This is to see all the shapes that we have, 32 images. Each image is 224 pixels square, and then 3 channels for RGB. This is just a patch again. The patch size, the number of labels in this case, which matches the number of images. We're just building a model for transfer learning. So this is the, just check this code again. So this is actually the model predicting, we've trained the model. It's quite good in terms of accuracy, actually, 96% accuracy. This code is actually visualizing the images and the predictions, so cat, bird, and so on. So it's all good. Now we're just doing a evaluation of the model, because we're using the internet validation dataset, so we already knew it was going to be good. Now we are loading some functions. Yeah. This first experiment is using the internet dataset for training and validation, and the test dataset is a dataset gathered from my garden. This time I need to save this notebook, so I don't want to keep repeating the same thing over and over again. Okay, so you can see the chart, the graph. It looks quite good actually. Oh. This was already saying it was already executed in another tab, but I only have one tab open, so I don't know. Anyway, so this is good graph. The training accuracy goes up, validation accuracy goes up, training loss goes down, validation loss also goes down. That's perfect. Almost too perfect. Oh, but then there's it kind of looks perfect, but when we actually evaluate this model against the test dataset, which is from my own garden, it does quite badly. Okay, now we are training the model. This is the second experiment, so I'm using the internet dataset for training, the garden dataset for training. This garden dataset is from my own garden, from my own Raspberry Pi camera. The test dataset, we still use it here, is the same. It's also from my garden. Number of epochs equal to 20. Dropout is 0.5. So this is a type of regularization. We basically severing 50% of all the connections in the neurons. And then early stopping equal to true is basically a way for us to say, okay, if the well, there's a method here, right? I can show you. So the early stopping, this is a parameter. We have an if statement here. If early stopping, then we add this keras function, this keras class, which is monitoring the validation loss. And then patience here is equal to 3, and this means that if within 3 epochs the validation loss keeps going down, keeps going up, then it will stop the training, and then it will pick the epoch that has the better weights, because it might actually start going bad in, I don't know, epoch 5, right? And then only epoch 8 it will stop, but then epoch 5 is when you got the best weights, and then, or the epoch 4, then it will pick the weights that were the highest. So instead of taking the weights from epoch 8, it will take the weights from epoch 5. Okay, next one. Okay, I've already run that. So the confusion matrix, it's not here, but no. Okay, so I need to display the confusion matrix. Why is it not showing up? Oh yeah, I know what it is. It should show the confusion matrix. Not fit. Sorry. This makes me a bit worried. Let me try again. Save. Yes. Saving. So we have now, we should have a confusion matrix somewhere. What is it? If I put it here, it'll show up. Nothing looks, it looks okay, right? Data frame. It should be fine. Not sure why it's not showing up. Display. But in the interest of time, I think it's because this method is not being used. Two methods. Okay, got it. So I'm supposed to be frame model, then display accuracy and loss graphs. If I want to actually see what the model is producing, I can call dataset model. Dataset 5. Let's try the test dataset actually. Okay. You can see the confusion matrix looks quite bad. 7 instances of birds. Okay, for birds it seems to be okay. For cats it's getting all of it wrong, and for foxes the same. It's really wrong. Okay, this is for the test data set, right? So if I try to test it against the actual validate the validation dataset from the internet. No, sorry, you'll see it's very good. That's fine. Okay, so the coefficient matrix looks perfect because this looks a bit. We need to make it pretty. You can see, right? This is like a diagonal. So if you see a line like this, that means the coefficient matrix is very good. Okay, so let's go. Let's just run all of this. This one is not good. As you can see this. So it was able to predict the birds, but then it wasn't able to predict the cats. It got well, only once, and the foxes got it all wrong. They thought it was a bird. Just to fly through them, and then we have to hear the Tensorflow code for conversion. I need to run this once again just to make sure it still works. This is part of the code that I lost last time, and I kind of copied this in the background. Well, after the last live stream, I spent some time trying to recreate the notebook that I lost. If you have any questions, let me know. It's a good time to ask anything. So last one more dataset to train, and we will be finished with this experiment. Actually, while this is running, I could already start going. I will make sure I go. Yeah, I'll show you something. So this is, let's make sure it's still running. So this is a previous GitHub repository I created for the Raspberry Pi. Okay, as you can see, I haven't done anything on this repository for 9 months, but you can actually see an article with step-by-step instructions, which I'll probably have to update because I'm going to work on this repository. You can see the instructions for the Raspberry Pi to update the Raspberry Pi, to reboot. Okay, this is to install Docker because I like to use Docker. It's quite easy, a good way to deploy APIs or any kind of anything that you've developed, and in a more or less containerized environment. I know I need to update also the Pi to the latest OS because I think I'm still on the old version of the Raspberry Pi. They always keep updating it. So the Raspberry Pi OS should be on. Yeah, I need to update that. That will take a bit of time. But then what's going to happen is the Docker image that I have here, they will have to be updated as well, because yeah, everything was compiled with the version of the OS that was valid at the time, but now it's things have changed, so I need to update it. Last time I did update it actually 9 months ago. It's active. But I can see pull requests. So the last time I updated this repository, I think it was also to update the image. Okay. First have a look at. Okay, it's still running. What else we have here? We have a Python code. So we have some random examples of object detection. Some of this code was from the Tensorflow. When I downloaded it from the Tensorflow website somewhere. It's related to the Coral USB, which I have as well. But the actual code itself, the one that we really care about, I'll show you which one it is. So you can see here there's a Docker compose. If you look inside the Docker compose, then you can see that we're starting this script, start camera.show, and then start camera.show is doing something cool. Okay, it's basically it's downloading the models that we're going to use, the models that for the camera from like a URL. And the idea is to make it as easy as possible for you to use the Docker container, use the latest models, and then start doing some. Yeah, basically you should be able to plug and play, right? If you use this Docker container, it will download the models automatically, and will start a Python program, which here is. So we'll have to modify that as well. So the Python program, I think it's this one. So here, the only difference in this repository is that we are using out-of-the-box pre-trained models, right? There was no transfer learning I did at the time. I just used the models as is. Yeah. This time we have our own image classification model, so this code will have to change somehow. But I have some ideas as well, which I wanted to discuss with you on how this is going to be done. Okay, so we have evaluated the two models here. Okay. Anyway, this is done in the previous live stream. I'm not going to talk too much about it now. This is the code to convert the TensorFlow models to TensorFlow Lite in the format that we need here. And then we have the work I've done. It seems like you got the function right. Oh, this one is not fully quantized. This one is just convert model to TF dataset. Did I run it again? Hope it works. If 2 TF1 is better. 2 TF1. Run it again. So it's converting to TF lite. So this is the normal TF lite. There's some optimization, like the way the algorithm works. It will prune from the graph, the TensorFlow graph, anything like that he thinks it's not being used. Right? Then it will do some conversion of data types, activations and weights. But this is like fairly conservative, right? So this method here converts model to fully quantized TF-lite. This is very aggressive because it converts all the weights and activations which are in 32 bits and float. It converts it to 16 bits for activations and 8 bits for weights, like inches only. Yeah. And that's how it saves a lot of space. You know, the file size is actually much lower. It's like 4 times less than, or 3 times less than a normal TF-lite model. And then it also supposed to be faster because you can use the hardware optimized, you know, the Edge TPU, which is a chip that you can connect your Raspberry Pi, and it will be able to do the inferencing much faster than the Pi itself can do, with less power usage. But you don't really need it. You can easily run the model on a normal TF-lite. It's fine. It probably makes a bigger difference when you're dealing with bigger hardware. Okay, and I think I remember what is missing now. So the next thing that I need to copy from the old notebook is the evaluation of the model. So because we also do some scoring of the TF-lite model to also compare it against the normal TensorFlow model. This evaluate model. We already have the code for evaluate, we just call it. So let's just try this. So test model. The TF model file is not defined because I didn't specify a file to save to. TF-lite model file. Takes a bit of time. Test mode. It should work after this. It's running. Okay, so while that's running, So this is class. Double check. Definitely the class. Start camera. It's calling the wildlife camera. Inside TF-Lite, okay? So the code itself, the code is here. You can see already some Tensorflow Lite code already here, anyway. We have also an option to use the edge TPU or use just the normal TF-Lite. This is object detection, which have like bounding boxes. The model I created is just the image classification model. Okay. And we have here some arguments you can pass in. This threshold I came up with just so because the model was quite bad actually, because it wasn't trained for the type of environment I have, so I had to lower the threshold. So I put this as a parameter. In general, you definitely want to have, you know, like there's a confidence level that the model will return you, like to see how confident it is that something is what it thinks it is. Could be completely wrong, right? So confidence is just that, a confidence that the model is right, that the model is right, not the actual result is right. It's more about the model. You can be dead right, you know. It's the same for a model. Okay, well, then we have -c is number of times to run inference. I don't remember why I put this parameter, to be honest. Maybe it's a trigger for how many times we should see something before we start recording the camera. That might be the reason I had that argument. Then this option is to enable the TPU for the edge TPU. Then here you can also specify what type of objects you want to detect. For example, if you're not interested in people or cats, you can just say bird, or you can just provide the comma at least in the comma, yeah. Okay, and then we have a debug is just to be able to see to open like an actual window which shows you the camera. I'm going to, in a separate session, I'm going to show you the Raspberry Pi, and I'm going to show you how this works as of now. Okay, so all of this code is basically just code that uses the Raspberry Pi APIs. So the Raspberry Pi gives you an API to use the camera, and we're using that, the Python API. And that's it. Okay. Where do we get these test images? Let me see. So test images. I think this was a method anyway that was supposed to test the model. This is like an array. Here. If I'm converting, this is a batch dataset, and then I found, and this is an iterator, right? So you can convert it to a NumPy iterator, and then put it as a list, so it gets everything. But to be honest, I don't think that's a great idea. What I can do for this example, I can just do .next. Test images and then test labels equal to this. So the data set, for example, can be like the let's start with the one which gives us good results. I don't know, depending on the experiment. This one for validation. So you can see, so this is giving us a prediction. Not right prediction, it's your own prediction, but this is it. So test model will take an image, its index, the actual list of images, and then a list of labels. Don't know why. Then the class names, this is being created, should be always the same. So the prediction is wrong, but like it depends on the experiment. So if I test this model, because I converted the model 5, I think. I think the best one to convert it would be some according to the test data set, that's the only accuracy I get. This one is like the best. So far, experiment 6. Test data set accuracy is 0.69. No, actually 0.84. That's good actually. Oh, but it's still, I mean, 84 sounds like high, but it's not that high actually. It's a lot of room for error, to be honest. So it's just because we got one which it was wrong, it doesn't mean it's bad. Okay. So, continue. So this is just for doing one image and checking how it looks like. And if you want to do a full evaluation, you can evaluate the model. So we can evaluate the model with the test data set. So the model type is the float. This is a normal TensorFlow Lite model. And then we can also evaluate against the fully quantized model. Yeah, I don't know if file names are still applicable. Yep, like model file is correct. Sorry, it's going to use the name is already there, so I don't have to rerun the cell again. Although that was another way to do it. There's a lot of debug here which I don't really want to have, so I'm going to comment it out. Here. This takes a bit of time because it goes through the whole test data set. Hi Dark Matter, nice to see you again. So we have that's why I had to comment out the code. The quantized model accuracy is 69%. That one. We still have some non-finite debug as well. Debug. definitely printing something. Anyway, it's much easier to see already. So floating model is 69% accurate. You get different results every time. Yeah, this one. You'll see less. So we are kind of done here. Cool, I've already given you a small review of what we have, right? And now let's just do some kind of a diagram. Diagram from before. This is when I was talking about full quantization. But today I want to talk about just kind of the plan for the Raspberry Pi. So the way it works, there's a camera. For the camera is in the Raspberry Pi, right? So this is the Raspberry Pi camera. Just for the sake of it, I'm going to keep this separate. So the camera sends us frames, okay? Yeah, all the time. So there will be a loop, and the camera will send a list of frames. Yeah, and it's going to be, I don't know, depending on what rate we want. Yeah, we can choose the rate, but like the Raspberry Pi can do, I think, 20 frames per second. 20 frames per FPS, yeah. If not more, I probably can do more, I can't remember. But it doesn't really matter, because we probably don't want to take full advantage of all this rate, yeah? And then there will be a Docker container running, let's call it one live camera. This is going to be our main process. Okay, so this, make it a bit bigger. I forget specific. This is just let's think of it as process that runs. Okay, so the one live camera contains some Python code, and then it has a loop as well. This loop. So this is how it actually works now. The code that's already in the Pi. In the loop, we get a frame. For each frame, it's not very smart, it just applies the for each frame. We call the object detection, yeah, basically. I don't think we are doing any, I don't remember doing any motion detection here. Okay, and what happens, right, is if object of interest detected, we basically send a notification on Slack plus create video clip. Yeah. Yeah. Yeah, and okay, so this is the current way of working. So what I wanted to do, I'm going to send a notification, right? So there'll be an arrow. So the way I had it working, it can send a notification to Slack, but you could also send it a notification to anything else, right? That you need to send to Slack. So yeah, image plus video clip. The reason I went with Slack at the time was because Slack already has a mobile app. You don't have to write one of your own. Yeah. So the way I want to modify this is to, I'm going to make things a little bit smarter, right? So I'm going to keep this. Just duplicating this. Oh. Paste. It's going to, so the wildlife camera will be checking for motion detection using an algorithm from OpenCV. So we'll implement an algorithm with OpenCV. Motion detector. So my approach is a bit different now. If motion detected, okay, this is using OpenCV motion detection. There is an algorithm you can apply. I've done it once. I will implement it again in a live stream. Yeah, and you can actually define how big you want, for example, the motion to be. Like, because sometimes you have like, okay, I have a tree in the back of my garden, right? If you just do pure motion detection without any discrimination, anything can trigger the motion detection, right? Even leaves moving. So what we do is we basically define how big. There's a few things you can do. You can define how big your motion is, like the actual displacement. And then you also can somehow filter some types of motion that you don't care about using some mathematics. Or you could also define an area of interest. But the only concern I have about that is because it's, I don't know how big my camera is going to move all the time, so I can't really guarantee it's going to be placed exactly where it should be. Yeah. But anyway, so I'm going to just do a general motion detection, and then I'll pass this to another microservice. Let's call it, this is going to be an out-of-the-box TensorFlow model. And this TensorFlow model, I think, all I want to know, okay, is there like a person to detect people, okay? Because I don't want to detect any people in my garden. I'm not looking for, well, I'm not looking for thieves. I'm just looking for animals, right? So if I detect people, I'm going to ignore it, or I'll call the police. Just okay. Ignore. Yes. Okay, this is not exactly the best diagram in the world, but you know, hopefully you'll get the point. So if yes, then do nothing. If we do detect anything that's not people, like an animal, like if the model says, okay, there's something there, but it's not a person, right? If not person, okay. So if there is not a person there, then we call the image classification model, yeah, that we've trained here. Yeah, this is where we're going to call, and this image classification model is going to tell me if it's a fox or a bird or something else, right? Or a cat. Or in the future, maybe I'm detecting something. Oh yeah, okay, I will share. It's actually on YouTube Studio. It's on YouTube Studio. I'm not listening to the song, so I don't actually know what song you're listening to. But I will look for the list of songs. Yeah, I muted the songs for myself. So if not person, then we call. If not person, then we call all the image classification model. Same thing we were doing before. And then we can decide, okay, if it's a cat, then decide on an action to do there. I also wanted to collect some training data. So in case I have false positives, right? Or let's just do a straight arrow. So this is basically it, right? And I wanted to collect some data, so I want to create a machine learning pipeline, because, you know, the point is, right, this is not going to, the model is not great yet, right? So I need to collect more data. So I need to make sure that in this deployment, I'm already thinking about collecting new data, right? So what can we do? We can maybe output it into a file store. Okay. You know, we can also detect, maybe we don't have to save every single prediction, right? In fact, if you look at what Amazon does, right? In Amazon SageMaker, which is a very popular framework, well, is a suite of tools hosted on AWS, right? That you have an option there to just say, look, I want to, for all my predictions, I want to collect 20% of the predictions, and these predictions can be used later to basically feedback on to your machine learning model, right? So this is really important, right? For a Raspberry Pi, I'm probably going to save this to a folder. Yeah, save prediction and image to a folder. Okay. Like obviously with the label, right? So it's going to be a file store. Yeah. It could be on a Google Cloud platform, on a bucket, or it could be on AWS in a bucket as well. And then we can use this too. So obviously we need to check that the predictions are correct, right? Because at the beginning they are definitely not right. Okay. So there will be some kind of, maybe I can create a small website where I can just check for all the predictions. Hi, Change Life, welcome to the stream. If you have any questions, let me know. So I'm here explaining just how the architecture for our machine learning pipeline is going to look like for the wildlife camera. So I have so far, okay, so let's put the person, curate. You know, Amazon, you have Mechanical Turk. It's not mechanic. It's actually people that basically you can just give the job. I think it's Mechanical Turk. Let me just remember. So basically, this is used in data science when you basically need people to manually label your data or do any kind of manual task. And this is important to create a high quality data set, right? You can actually just send, you can use an API or something like that. You can just send a task to Mechanical Turk. Yeah. And that's something we could do, but obviously this is just for, like, this is a pet project literally, right? This is just to learn. It's probably going to be me, or, you know, if anyone wants to volunteer, I'm happy. So, creates predictions. So basically the job is, okay, did the model get it right? So we'll be able to see on like maybe a small web page saying, okay, what's the prediction that the model made? What's the actual ground truth for this? So I will be able to label it. And then with that data, we can basically use this data and we can save it on Kaggle again, and it will go back to the, basically it will actually improve our machine learning model. For well, I didn't show the pipeline for training the machine learning model here, but give new data. Right. Actually, what I'm showing you here, okay, this is for this is actually applicable to many projects in machine learning. When you, in fact, many projects in machine learning don't get as far as creating the whole pipeline. They will just have someone manually creating maintaining the training data and validation data and the test data. A lot of these projects are actually just research anyway, so they will never go into a point where it's fully automated. But if you want to actually deploy this into like a scale, like what Google would do or Amazon would do. You would need to have a way to, you have a model, you need to improve it all the time, so you need to somehow feed back data to it for training. To learn this architecture, I think you just have to have seen a few machine learning projects to be able to, because what I'm actually showing you here is not like something that, it's what is practiced in a way, like it's not something that is necessary in the book, but if you look at enough machine learning projects, you always have to have, for example, it's always well defined, right? There's training, there is deployment to production, so as in a microservice, which is something I haven't mentioned yet. Okay, so these are microservices. So the architecture is something I'm sure there will be a book with showing you an example of Mlops architecture, but I don't have one. In fact, if you look at the Amazon SageMaker documentation, I'm sure they'll have some examples there. And if you're looking for certification, maybe it will help if you tell me first of all, what are you currently, what's your current background? Are you like already in IT? Well, what do you do? But if you want to get into data science or data engineering, I would say that's a good backdoor. Normally, data engineering. Yeah, have a look at how SageMaker works, because it has a well-defined. It's actually the most popular data science cloud service. Let's call it right now. Even more than Google's, I think, is it Vector AI or something? Vex AI. Is it Vector? Vertex, yeah, sorry, Vertex AI. Yeah, so Google actually is a bit behind Amazon on this, which is quite interesting, right? You know, Google is the reference in terms of AI, but Amazon has somehow created SageMaker, and SageMaker is far more popular at the moment. There's a Tensorflow certification, by the way, but that's probably going to be a bit more technical. For Amazon, you have training. There's Coursera courses that are on artificial intelligence. There's a new one which I'm actually looking to take. What's it called? Coursera Data Machine Learning. Andrew NG, right? He has also some, I'm sure, some topics on this. Yeah, this is a new specialization. I'm actually thinking of taking this as well. I would be going through. If you have time, this is where you want to learn with this, with Andrew NG. It provides machine learning. So you get all the theory, and I'm sure you will be talking about Mlops, right, and deployment, right, of machine learning in a real environment, right, in a real enterprise. Okay, so you are trying to get into university. Okay, yeah, like data science. Yeah, data science, computer science, anything that's related to. You can always specialize in data science later. You might want to start more in as a developer, because data science can go very theoretical and maybe with too much focus on numbers, I guess, right? But if you start as a developer, you can also go into data science later if you want to. But yeah, why don't you just take this course if you have time? And then you also have a better idea what you want to do at university. And he's the top. Android NG is almost like the Bible for artificial intelligence right now. Okay, cool. So we have gone through the what I'm planning to do, right? In terms of like, this is the architecture. So we've done this very initial this is a starting model for me, right? This is, it already has some data from my Raspberry Pi camera, but not enough. So what I want to do, I'm going to deploy it anyway, put into the Raspberry Pi inside using Docker, and then I'm going to run that, right? Collect some data, check whether, I'll use then that data as my training data, and then I'll feed it back, and soon enough I'll have a very good model. Oh, did you already do that course? The whole thing, the specialization? So you are definitely in a good direction already. So okay, yeah, I think I'm finished for this session. But if you have any more questions, let me know and I can answer. In the meantime, I'm going to save this into a GitHub gist. Be able to, I'll put this in the description. Oh wait, too far. There we go. Copy. Put this into the description now. So try to update the Kaggle notebook at some point. Not. Okay. That's too much. All right. Thanks a lot for joining this live stream. Don't forget to click the like button, and I'll see you again soon. Happy coding!